The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video: Square Root of Multiple Digit Numbers. Example: 186,624. Let us set the number 186,624 by leaving 3 columns in the right side of the abacus. That is, the lowest digit 4 of the number should be set in the thousands column, 2 in the 10,000s column, 6 in the 100,000 column, and the numbers to the left. We do not know whether the number will give a whole number square root or that as decimals. Therefore, we always leave 3 columns in the right side of the abacus in case of the square root having decimals. In case there are no decimals in the square root, the 3 columns will always be empty. We can understand this concept when we deal with the numbers which give square roots having decimal values. For the present, let us leave 3 columns for the decimal portion of the square root. We had mentioned that for calculating the square root, we have to group the numbers from the right side. Therefore, 24 is a group, 66 is another group, and 18 is another group. For the purpose of calculation, we can consider the groups in order as 18, 66, and 24. Take the first group 18 and consider the perfect squares there. 4, 9, and 16 are the perfect squares in 18. Now 16 is the highest perfect square, and therefore take the square root 4. Set 4 to the immediate left of 18 and subtract 16, which is nothing but 4 multiplied by 4 from 18. And at this stage you are left with 26,624. In the next stage, double the number 4 and set 8 in the extreme left of the abacus. Consider 26 of 266. Ask how many 8s in 26. You get the answer as 3. In the case of small numbers, you need not have an assumed quotient. Therefore, straight away set the number 3 to the right side of the first digit of the square root 4 and to the right side of the number 8, which is set in the extreme left of the abacus. Now multiply 3 with 83, that is 3 multiplied by 8, which is 24. That should be subtracted from 26. Now 3 multiplied by 3, which is 9, that should be subtracted from 26. That gives us 17. Now you are left with 1724. Look at the square root now. In this problem, you are going for a third digit in the square root. In every stage of division, we have to double the square root before going for subsequent calculations. In the square root section, we have 43. That should be doubled, and therefore clear 83, which is set in the left extreme of the abacus, and set 86 there. Now consider 86 and 1724. Look at the first digit of the dividend and the divisor. Here also you get small numbers. Ask how many 8s in 17 by saying 2. Set the 2 to the right side of 43 and to the right of the number 86. Multiply 2 with 862 and subtract that from the number 1724. That is 2 multiplied by 8, which gives 16. That should be subtracted from 17, which gives the remainder as 124. Now multiply 2 with 6, which is 12, and therefore subtract 12 from 12. Now we are left with 4. Now multiply 2 with 2, which gives 4, and that should be subtracted from the remaining 4. No number is available in the abacus as a remainder. You will get the answer as 432. Let us take up some more problems similar to this and find out the square root before getting into the square root which give decimal portions.